Hey, physics team. So we're back with another question. This is a paragraph length response one. Yeah, and it's a little bit tricky. So let's just go through and remember, first step is you always go through and read the problem. I'm going to summarize it real quick. So a block's hit, has an initial velocity coming up. It goes a certain distance. There's friction on the way up, and there's friction on the way back. So our first step is it says draw a free body diagram. Okay, so in both these cases, we know that there's a weight, there's a force of gravity. And we know that that is whatever the mass of the block is times gravity. All right, so we know that there's the force of gravity. It's also on a surface. So anytime that something's on a surface, there is a normal force. All right, there is a difference though. If this is going up, well now it has friction, right? So there's friction, so there's one more force on here. And so this force is friction. So in this case, the friction is going to oppose the direction it's traveling. So on the way up, it's going to be a frictional force going down the ramp. And then on the way down, the frictional force is going up the ramp. So there is my free body diagram. All right, hopefully you scored those points. Let's look at the next section here. So we have this next one. Now we're gonna say, okay, on the way up or on the way down, which one took a longer time? So this one's a little bit tricky and we have to write a paragraph length response. Okay, so let's look at this. So if I analyze the problem, remember I said that there's a kind of a trick that you can do. We're looking at the acceleration. If we rotate this thing and we just look at, like, let's say the ramp is horizontal now, makes things a little bit easier. So we can see the acceleration is going down the ramp. And what's pulling it down the ramp? Well, gravity, and specifically, it's only this component of the gravity that's pulling it down the ramp. And now we have friction is going down the ramp too. So this is on the way up. So there's two things that's causing it to accelerate down the ramp, friction and the weight. Okay, down here now, and now we have the component of the weight pulling it down the ramp, but friction now is going in the opposite direction. So let's do this. We're summing the forces and we're setting it equal to mass times acceleration. So we're going to see which one has a bigger acceleration. Well, here we have frictional force going down. I'm going to call it negative. The weight component is down. It's negative. So we can think here that the magnitude, let's forget about the negative. We just want to know the size, that the acceleration up is greater than the acceleration down because here we have opposite signs. So we can just say that the acceleration up is greater than the acceleration down. All right, so here's how I would write it. So in the paragraph response, I would say there is more net force for the way up. So because the frictional force and the weight was pulling it down, so more net force for the way up. So the acceleration for the way up is greater than the acceleration down. So two big statements. We got the net force is greater for the way up. So the acceleration for the way up is greater. Okay, my next statement is going to say, well, if the acceleration is greatest on the way up, then the change in velocity is greater for the way up. If it has a greater acceleration, it's going to have a greater change in velocity. So I can make this statement. V initial is going to be greater than V final. Because as the acceleration goes up, the change in velocity increases. And you can back this up with the kinematic equation. Like if you look at this kinematic equation, this says I can rearrange these for my up and my down here. And here it's saying as my acceleration goes up, my change in velocity goes up. As my acceleration goes down, my change in velocity goes down. So they're directly proportional. So I can make this statement here. Okay, so I can make my final statement that as delta V goes up, T goes down. So that means that the time up is going to be less than the time down. So as delta V goes up, the time goes down. As delta V goes down, the time goes up. So therefore T down is greater than T up. Okay, I hope this helped. This was a really challenging question, so let's see how many points you would score. Okay, so really quickly to talk about the points for the free body diagram, you get 1 point for for frictional forces labeled in both down the ramp and up the ramp. So you get 1 point for having correct frictional forces, and then 1 point for having correct normal forces and gravitational forces. All right, the second part was worth 5 points, and I'm just going to refer back to this. So it's 1 point if you state that there's more net force, 1 point if you state that the acceleration up is greater than down, 1 point if you state that the initial velocity is greater than the final velocity when the block's back down at the bottom of the ramp. And knowing that some kind of justification for that T is smaller, that T up is less than T down. Okay, hope this helped.